this riser piece, and this riser piece, and that would tell us the square foot area of lumber we would need. Sheet number 5 shows us the third and fourth floor plan, and once again we have the wood stud partitions here. And we have to remember, though, that if we find a measurement or a calculation off of this sheet, it's really covering 2 floors, and that's where the test might catch us. The other detail that's on this sheet is a detail about that marble stool assembly that we talked about when we were trying to find the area of the windows for purposes of glazing. Now what I'd like you to do is stop the video and tell me what the total square foot of all the glazing is above elevation 2684. 2684. When you start hunting for this, you're going to realize that they don't make it easy for you to find either the length or the height of this glass. But essentially, you're looking at the fact that you have 2 lengths of glass per side of building of 82.34 feet in length. And then you have 2 more sections of glass that are 164.68. And then you have 2 little sections of 32 feet each and 2 little sections of 64 feet each. And when you add them all together, you get 457.36 lineal feet of glass length. When you then adjust the height of the glazing by subtracting the height of the marble stool from the floor to ceiling height, you get 7.17. When you multiply these numbers together, this is the amount of square feet that you have. And you want to look through these plans and see if you can come up with it. If you have a problem, bring it to your instructor. Sheet number 6 is the roof plan. And we have a detail on this sheet that is somewhat unfamiliar to most of us. And they're talking about an equipment screen or mechanical equipment. But what is significant about this detail is it refers to a single L4 by 4 by 1/4 angle 7 feet long. If you remember from prior modules, there is information about angle iron in Walkers. And you can look up this piece of angle iron and find out how much it weighed per lineal foot. That times 7 will tell you how much each angle weighs. And you might be asked a question for the total weight of all such angles. The detail of the roof itself shows us a little bit more about how the building is configured. Generally speaking, however, for residential, general, and building contractors, there's not a lot of other questions that will come off of this particular sheet. However, roofing contractors might need to calculate the area of this shape so that when they take into account the selvage or the area of lapping, they'll be able to come up with an accurate amount of material needed to roll roof, for example, this roof. We have covered the intervening sheets, so turn to sheet number 9 of your plan set. And this sheet is possibly the busiest of all of the sheets. There are more questions that can come off of this sheet, perhaps, than any of the others. The first kinds of questions that might come off of this have to do with the details that are on this sheet. Here we have a detail of an elevator pit. Here we have a detail of a curb and gutter. They're showing us these details because they probably intend to ask us questions about them, such as how much concrete is it going to be necessary to pour the curb and gutter. As we said earlier, and as you have an example of, you can analyze this shape and come up with the cross-sectional area. Then, multiplying it by the length of the curb, you would find the volume of concrete needed. The elevator pit is a similar kind of a concept. But in dealing with the elevator pit, you have to remember that what you see here is not really what you get. This is a closed rectangle. It does not appear to be closed because they have cut through it. However, if you were standing inside of these things, you would be surrounded on all 4 sides by walls. Rectangles have short ways and long ways. For example, this simple shoebox is such a rectangle, and if placed down like this, I could be standing inside of it, and I would be inside the rectangle. If I were to cut the rectangle open and look at it from the side, I would be looking at something like this. This is telling us important measurements. It's telling us that the inside measurement of this rectangle is 7.2 by 17.4, which translated into our shoebox is telling us that the long side would be the 17.4 and the short side would be the 7'2". two inside dimensions. And so if we needed to find out the volume of concrete in this pit, and you can refer to your CRAM workbook to work this particular problem out. It's also given to you as one of the problems in your sample test here. But the simplest way to find out the volume of a shape like this is to take the exterior measurements, add 8 inches and 8 inches to each of these two measurements. Take the exterior measurements all the way around to the bottom, all the way around, and multiply them all together. And what you will get would be a solid cube, which you could pretend was full of concrete. Then you could multiply the interior dimensions all together, and you would get the void inside the solid cube. You subtract the void from the solid, and you're left with the net. If you turn this page the other way, you have the column and pile cap schedule. In this case, they have identified the various locations for a mile marker, pile marker, 1 and 2 and 3. So if you remember when we had to count the locations before, that was an exercise. Here they give it to us. We could just add these up, come up with our 19. But sometimes they don't give us these, and we might need to count them. What they're telling us is each location marked thusly exists in these positions and consists of a column which is made up of two pieces of steel. One piece of steel is a W10 by 49. The other piece of steel is a W10 by 54. We might be asked the total weight of this column, or the total weight of all the columns such marked. And what we need to do would be to find out the weight of each of these pieces. Now, on the W10 by 49, the 49 is significant because it means it weighs 49 pounds per lineal foot. So if we find out what the distance is between here and here, we will find out how much it weighs if we multiply it by 49. We have to be cautious here, however, because we have a splice elevation of 2883. And at first glance, it may appear that we're going all the way up to 51.33, but we're not. This piece of steel is only extending to the top of the column, which is 50.66. So the distance is going to be the difference between 50.66 and 28.83. This second piece is a W10 by 54, which means that we have 54 pounds per lineal foot of material. However, this is extending from an elevation of -6 to the splice line of 2883. We don't want to get confused. The distance between these two numbers is 3483. We also have to take into account that this piece of steel is resting on something. The notes, which we always have to read whenever we're reading an exhibit, tell us that there is a base plate and there is 2 inches of grout that this is resting on. So we would have to take this gross measurement of 3483 and subtract approximately 4 inches in order to get the net measurement, and then multiply it by 54 pounds per foot, and that is going to tell us what our weight is for that piece or that section. We add the two sections together, and we come up with the weight of that piece of steel. Now, question number 14 in your set of questions for this exam, in the AM section of the exam, is a good example of this type of calculation, and you ought to stop your video now and do question number 14 to see if you've got it. Returning now to our schedule, there is further detail about the composition here. First of all, we're told that these metal base plates are 18 by 18 by 1 3/4 inches thick, and we might be asked for the weight of all these base plates. Well, all we have to do is accurately multiply all three of these dimensions together. Now, when I say accurately here, you have to realize that since steel is pretty heavy, a very slight difference in a measurement can make a big difference at the end of a result. So we either want to work with inches here, which would be awkward, or we want to go 3 or 4 decimal places if we're going to convert this to decimals. So we would find out the mass or the volume of steel in the base plate, and then we would multiply that by the weight of 1 cubic foot of steel, which we would find in walkers. And when we talked about steel in the vertical construction modules, we pointed out the section dealing with steel in walkers. And we would find out that it's 489.6 pounds per cubic foot. So if we found out the volume of steel and multiplied it by 49.6, we would find the weight of one of these base plates. If we then multiplied it by the number of base plates that we had, we would find out the weight for all the base plates. The pile caps are also described. The pile caps are 4, 4 by 4, 4. If we had to find out something about the reinforcing bar inside here, we'd have to remember that there was cover. Perhaps there is a note somewhere that tells us in this case that the cover should be 2 inches. They're telling us that the depth of this is 2 foot 4 inches, and that there are 7 number 9s each way. So if the cover here were 2 inches, each number 9 would be 4 feet long. And so we'd have 7 of them going one way and 7 of them going another way. We also have to notice that they tell us how many piles are in here. And notice we can see that by seeing the number of circles. However, if we look over at column number 3, we will note that while there are no columns, there nevertheless are piles. Now, this kind of thing can be confusing because they can ask us a question about all the piles in the building. And if we take it as read that there are no piles where there are no columns, we will get it wrong. So we have to keep heads up on that. Sheet number 10 is the second, third, and fourth floor framing plans. The first thing to take a look at here is we do have a detail about a corrugated metal deck. And so we might need to find out a volume of concrete here. We take the 4 inches and add half of the 1.5 inches. So we have 4.75 uniform thickness to this inches. And then if we found the length and the width and converted the 4.75 to decimals, we would be able to find the volume of this particular shape. As far as the framing plans themselves go, let me call your attention along the piece of steel that is between 1 and 2. You'll notice that this is a W18 by 50 piece of steel. How long is this piece of steel? Well, your eyes at first might deceive you because of this little 12 inches here, but this piece of steel is 23 feet long. The one next to it, an 18 by 50, 24 feet long. The one that is extending along one between A and B is a W18 by 40, and it is 23 feet long. But now let me call your attention to the pieces that are labeled W16 by 31, which is found in between A and B and 2 and 3. This 1631 is resting on something. And what it's resting on is an arrow. And what they're trying to tell us here is that there are W16 by 31s here, sure, but the pieces of steel are actually running this way. They're running perpendicular to this arrow. The arrow itself is saying everything I'm touching or running over is one of them. And so I have W16 by 31s. They are each along here 23 feet long. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of them. Let me make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 of them. In the PM section of the exam, question number 11 deals with this, and is a good question for you to do. So I'd like you to take a moment and shut the video off and do question number 11 in the PM session of your exam. Sheet number 11 shows us the roof framing plan, and here we see several details. First of all, we see the detail of the frame wall that we looked at earlier, and it's a 2x4 wood studs, 24 inches on center with single studded column boxing, no splicing in the studs. And it's showing us the actual height of the wall here. Notice this extra 6 inches above the finished ceiling. And notice there's a 2x4 blocking at this point. We're also shown here a planter, and you want to refer to the cram workbook for this planter. There are a number of questions that can be asked about this shape, and it's an unusual shape to work with because, once again, if you were standing inside of it, you'd be surrounded on all 4 sides by walls. There's no opening here. It just appears that way because they've cut it open. And also, we might be asked about excavations underneath the footing, and what we have to remember is in all dimensions, the excavation runs to the outside edge of the footing. So if we were working with measurements here, this 20 by 10 is telling us that it's the dimension from wall to wall. If we wanted to get to the outside edge of this, we would have to maneuver the numbers to find out what the distance is from this point to this point. In this case, the way we could do that would be to get the center line measurement here. See, this 20 by 10 is to the outside of the wall is 8 inches thick. So if we subtract 4 inches from one side and 4 inches from the other side, we subtract that from the 20-foot dimension, we get 19 feet 4 inches. And over here with the 10 feet, we get 9 feet 4 inches. And that's our measurement to the center. Since the bottom of the footing itself is 1 foot 8 inches long, or 20 inches, to get from the center line out to the outer edge must be 10 inches. So if we took the 20-foot dimension and subtracted the 8 inches to get to the center, we would be looking at 19 feet 4 inches. We would then add 10 inches to that to get to the outside on this side, and 10 inches to that to get to the outside on this side. So 19 feet 4 inches plus 1 foot 8 inches will get us to the outside of this going in the 20-foot direction. In the 10-foot direction, we do the same thing. We get to the center line, so we subtract 8 inches. That would mean there's 9 feet 4 inches from the center to the center. We then add back in 2 sets of 10 inches. So 9 foot 4 inches plus 1 foot 8 inch will get us to the outside measurement in the short way. The rest of the sheet is very similar to the previous page, with an additional bit of information that now they're telling us we're going to be using joists, 18H6 joists, for example. What I'm pointing out is between 3 and 5, or 4 and 5, and D and E. And once again, this is resting on an arrow, but in this case, they're telling us that there are 11 of these things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 18H6 joists. And again, these joists are running this way. They're 24 feet long. We also noticed some details here. Earlier we saw a detail that talked about that angle iron, and now we're finding out how many of these angle irons we actually have by counting these. Sheet number 12 is showing us this critical path method, this spider's web. And you're going to want to go to the cram booklet to see how this works, but you're going to want to get familiar, and at some point you're going to want to solve this critical path. The process is simple, but you want to look at the cram workbook to help you do this. And then you're going to be asked some questions about the critical path, both in terms of nomenclature, words, and also in terms of what ifs. What happens if you have a delay here or a delay there? And again, we'll go over this in the cram itself and take a look at the cram book to get some sense of how to solve one of these. And if you think you're up to it, give it a shot. See what you come up with for the total duration of this job. The final sheet of our plans shows us some abbreviations over here and shows us some of the material and symbols for the material over here. It also shows us this business. It also shows us this business about the section detail and the direction of view. Now, we just took a little while and went through the first set of plans that you have. You have another set of general contractor plans. What you ought to do right now is shut the video down and go through the second set of general contractor plans. Follow along that reading plans bulletin and see if you can come up with the same kind of measurements and issues as you saw on this set of plans. Again, if you have any questions, bring them to your instructor. So I want to thank you. We hope that you've enjoyed our modules. We hope you've gotten what you came here to get. If you have any questions or comments, ways in which we can improve our material, please let us know. It's very possible that I've already had a chance to meet and work with you in one of the crams. If not, I look forward to doing so. I think at this point you can appreciate that we have covered in a very thorough way the breadth of this subject. And to take the exam, all that's really going to be necessary on your part at this point is to make sure you have a general familiarity with how to use the reference books, work through the 1 or 2 math problems that might give you a little trouble, and then get a good night's sleep before the exam. The exam and passing it requires 2 things. The first is that you're trained, and the second thing is that you're up for the activity. You want to be feeling your best, you want to get a good night's sleep, and you want to go in there with a great deal of confidence. There's one last exhibit I want to call your attention to that can help you bring it all together. You may remember at the very beginning of the course, we turned your attention to an exhibit published by the state. that we called the survey that showed the proportional distribution of the questions by percentages. Well, we've taken that distribution and we have tried to indicate what sections of the cram book and what sections of our modules those areas relate to. And I think if you take a look once again at this proportioning, you'll get a good sense of how prepared you really are. Well, that's about it. I enjoyed this presentation and look forward to seeing you. And as always, I'm Bob Tannenbaum, and I'll be seeing you at the cram.